Hi, welcome to my channel Industry 4.0. So, today in this video I will teach you about the ensemble methods in deep learning. Also see the complete video to learn this topic. Please like, share and subscribe. Ensemble methods in deep learning. Introduction. Ensemble methods in deep learning associate the output of machine learning models in various stimulating means. We were unmindful of the power of ensemble methods after years of working on machine learning projects. Because this topic is typically ignored or only given a short-lived outline in utmost machine learning courses and books. By testing competitive machine learning scenarios, we approach to know about the power of ensemble methods. As the Kaggle competitive platform compromises an impartial analysis of machine learning methods. In the data science world, ensemble learning is rapidly emerging as a good choice for machine learning models. Ensemble learning has reliably overtaken competitive metrics for the past few years. In this post, we will learn about the ensemble methods in deep learning in depth. Description. Ensemble learning is a grouping of many machine learning methods done together in machine learning. Ensemble methods commonly produce more precise solutions than a single model would. The benefit of ensemble methods. Let's assume that we want to invest in the stock market. We are involved in a specific stock, though we are not assured about its future outlook. Therefore, we choose to look for advice. We reach out to a financial advisor who has a 75% correctness in making the right predictions. We agree to check with other financial advisors, who offer us alike advice. What would be the accuracy rate of this collective advice in a case where each of the advisors suggests that we buy the stock? The collective advice of several specialists beats the accuracy of any one advisor. That would happen especially in diverse financial situations. Likewise, ensemble methods from many machine learning models incline to have a widespread presentation than any single machine learning model. That will occur especially in wide-ranging conditions or cases or in the long run. Classes of ensemble methods. Ensemble methods fall into two comprehensive classes. Sequential ensemble techniques. These methods generate base learners in a sequence. For example, adaptive boosting as AdaBoost. It supports the dependence between the base learners. The enactment of the model is then enhanced by allocating higher weights to formerly distorted learners. Parallel ensemble methods. In these methods, base learners are generated in an equivalent format. For example, random forest. Parallel methods implement the same group of base learners to reassure independence between the base learners. The freedom of base learners meaningfully decreases the error due to the application of averages. Types of ensemble methods. Bagging. Bagging is largely implemented in classification and regression. This is the short form for bootstrap aggregating. It upsurges the accuracy of models over decision trees. That decreases variance to a huge extent. The decrease of variance rises accuracy. That eliminates overfitting and is a challenge to several predictive models. Bagging is categorized into two types. Bootstrapping. Aggregation. Bootstrapping is a sampling method where samples are derived from the whole population with the replacement procedure. The sampling by replacement method supports making the selection procedure randomized. The base learning algorithm is run on the samples to complete the technique. Aggregation in bagging is completed to include all possible consequences of the prediction and randomize the result. Predictions will not be correct as all results are not put into thought deprived of aggregation. As a result, the aggregation is created on the probability bootstrapping procedures. Bagging is beneficial since fragile base learners are united to make a single strong learner. That is more established than single learners. It similarly removes any change, thereby decreasing the overfitting of models. Boosting. Boosting is an ensemble method, which learns from preceding predictor errors to create well predictions in the future. The method chains various weak base learners to make one strong learner, therefore meaningfully refining the predictability of models. It does work with the arrangement of weak learners in a sequence. Due to the weak learners learn from the next learner in the sequence to create better predictive models. Boosting forms. Gradient boosting. Adaptive boosting, AdaBoost. XGBoost, extreme gradient boosting. AdaBoost usages weak learners in the shape of decision trees that mostly comprise one split. AdaBoost's key decision stump includes observations carrying like weights. Gradient boosting enhances predictors successively to the ensemble. At their preceding predictors precise their successors, thus growing the model's accuracy. The gradient of descent supports the gradient booster classify problems in learners' predictions and pledge them as a result. XGBoost creates the use of decision trees by the boosted gradient. That provides enhanced speed and performance. It relies deeply on the computational speed and the presentation of the target model. Stacking. The stacking ensemble method is regularly mentioned as stack simplification. This method works by permitting a training algorithm to ensemble some other similar learning algorithm predictions. Stacking has been effectively applied in regression, density estimations, distance learning. Stacking can be used to quantify the error rate involved during bagging. Variance reduction. Ensemble methods are models for decreasing the variance in models. These are ideal for growing the accuracy of predictions. The variance is removed when many models are joined to form a single prediction. That is selected from all other possible predictions from the combined models. Conclusion. Ensemble methods may support us win machine learning races by planning refined algorithms and producing results with high accuracy. However, they are often not favored in industries where interpretability is more important. The efficiency of these methods is irrefutable. Their benefits in suitable applications may be marvelous.